Okay, so in this video I'm going to be showing you how to face a part. This is a scrap piece of aluminum that I have, and you can see it's got all sorts of shapes on there and kind of sides. We don't want that anymore. We want it to be flat across the end. And let's make it a nice number while we're here. Let's bring it down to 0.75. That should be good. And I'll show you two different ways. Let's go down to 0.5, 0.625. And we can mark it right there. A little machinist trick is to mark it once very lightly and then put some Sharpie on there and mark it again very lightly. And now you can kind of see more clearly where that line is. So that's how far we're going to take it down. Right now we have the wrong tool in there. So I'm going to switch this tool out, because for facing a piece of metal, you cannot use a drill chuck like this. These don't do side loads very well because you only have those three little jaws to grab onto. So what we use instead with our end mills, this is a 2-flute end mill because it's got 2 flutes. And this is a 5/8 end mill. And I'm going to choose the 5/8 collet. Now you can see how much more surface area there is to clamp. And these collets are split on the side. And when you squeeze it tight, when you pull it tight in the spindle, those will flex and it'll grab onto here even tighter, just like that. That's how it fits. And remember, this has a little groove in it for the little pawl in there to grab. So put that in there. You have to hold the tool and the collet together, push them all the way up, and then tighten the drawbar until it's hand tight. And normally this won't come out, so we want to make sure this doesn't fall. These are very brittle, they're very hard, and if they hit the hardened surface of the vise or the table, it will chip the edges and make them not very good at cutting anymore. So I'm going to tighten that up and put my wrench down. And I'm going to change out these parallels so that they're the appropriate height. Turn these off. And we're going to do some face milling. Just like that. So when you put this in here, you don't normally want it to be biased to the side. You want things to be in the middle so it doesn't make the vise go like that, but it's okay in this case. You just want to make sure not to grab it too tight, just tight enough. So when I raise up the table, I want it to be just high enough that when the quill is all the way up, the bottom of my tool is not going to touch the top of the part. That way I can move it around more freely. And when I go to make the cut, I don't have to have the quill all the way out, because that will add more vibration and we don't want too much side load on this thing. So I'm going to pull this down just a little and lock it. So I'm not really going to be measuring anything while I'm doing this. This is just to show you the mechanics of how it works. And before I do that, let's talk about climb cutting and conventional cutting. So these end mills are directional. They want to cut clockwise, like most drill bits. And when you're doing that, you're scooping away material, right? Now, if I'm traveling this direction and the tool is cutting like this, it's scooping and it's throwing it away as I go down. This is called conventional cutting. Now the opposite of that, the tool is still spinning this direction. The tool always spins this direction, but now I'm traveling upward. So now every time I spin, it wants to pull the whole part up this way, or actually down this way. So tool stays still and the part wants to move. That's going to cause a lot of pull on the machine, and we don't always want that. Climb cutting does create a better surface finish like this. So it'll be a little smoother on the side, but better for the machine is to conventional cut. If you have questions about that, let me know later, or come back to this video and look at it again. Okay, so I'm going to turn on the machine and set it to a slower speed, like about 900 RPM. Slow that down a little bit. I'm going to raise the table up. You don't want to cut too much, only about, I don't know, maybe 200 thousandths at a time. When you're doing a cut like this, it's about 200 or 300 is plenty. If you do more than that, you'll stress out the machine. And we're going to take a little bit of oil, put a little bit of oil on the side of the part there. And I'm going to be conventional cutting because the tool is spinning that way and I'm traveling with it towards me. So it'll be scooping away as I'm traveling. So I'm going to bring it over to the part here and move the x-axis just until it touches. And you can kind of hear, there it is touching, and it makes little tiny chips. So now I'm going to move away from it and go, I don't know, about 10, 20 thousandths in, and just move it along the part nice and slow. Now you can go a little bit faster than this, because this is not a very deep cut, but you will hear for sure if the machine is not happy that you're going too fast. So I'm going to run it back because this is not my final cut. So while the tool is running, I'm going to take a little bit of air and just blow the tool clean. And I can turn it off and blow the rest of the stuff clean. So now we have a surfaced part. I'm not going to go into how to measure stuff right now, but now your part is flat. We don't have all those rough edges on it anymore. You can see there's a decent surface finish on it. It's got a little bit of bumpiness to it, but that's okay. So now let's turn the part and I'll show you how to cut around the sides. This is facing because we're using the side of the end mill. Actually, while we're here, now is a good time to talk about how to do another skill. Now I said I wanted to make this in inch and 5/8, so 1.625. Now this part overall, now that I've faced the side of it, is, let's make sure we can see here, is 1.911. So let's put that in our calculator. We can say 1.911, that's our overall, minus 1.625. That leaves us with 286 thousandths to take away. So I'll show you how to set the Z height in this. So let's flip that around so we can see it. Now I have the right parallels in there because most of the part is being held and I can still reach everything that I need to. I'm going to put that in there. There we go. Now it's nice and solid there. And the way we're going to set the Z height is moving the table up just a little bit. So that there's just a little bit of space there. And I don't know if I mentioned it before, but you need to make sure that the quill is locked so that it doesn't move. We don't want that to move. And what I'm going to do is move this over to the side just a little bit. So I'm going to turn the machine on. And when it's on, I'm going to raise the table up using the handle here. And I'm going to listen and watch for it to come in contact with the part. So just barely, barely, barely touching. Move that handle so it's a little bit easier and watch it. So now I'm getting pretty close. Now I'm going to watch the top surface and you can tell when it touches. And I'm just moving this very, very slowly. There we go. So now it's touching. That is my Z height. I'm going to move it off to the side and turn off the machine. So the tool just barely touched the top of the part. I'll show you what kind of mark it left. So you can see the tool left just a little bit of a mark on the top of the part. And that's, we're going to say, where the 0 point is. So to set the 0, we're going to look at the Z handle. And there's a little nut on here. This thing right here, this is the jam nut. So I'm going to loosen that up. And it's hard to see because this machine is old. But that's our indicator that says where we are. I'm going to set this to 0. Now, the machine needs to be biased a certain direction. We're going to be lifting the table upward, which means we're turning the handle clockwise. So when we do that, I'm going to move this handle so that it's biasing clockwise. So it's already moving the direction we want to go. And that sets the backlash. So you can see it moves a little bit back and forth. And we don't want that. That'll give us a bad measurement. So I'm going to bias it forward. Set the dial to 0 and lock it very carefully. So now this is my 0 point and I can count with this. Each of these tick marks is 1/1000th of an inch. You can see it written there. It's 1/1000th of an inch. And every full rotation, so every time I come back to 0, I will be at 0.1 inches. And you can kind of tell because the one over here is 90. So whenever I move something, if I move it too far this way and I go, oh shoot, I need to go back to 0. I need to go past 0 because of the backlash and then move it back to 0. So that's my 0 point. Because of that backlash, we don't want that. You always want to be traveling in the clockwise direction because that's how we set it. Okay, so I'm going to continue with conventional cutting, which means I need to be traveling around the part in a counterclockwise direction. That way I'm scooping as I'm traveling. Let me go ahead and turn on the machine. Put a little bit of oil on. And now I'm going to set the depth to 50 thousandths. So I've moved the table up 50 thousandths using the setting there. And I'm going to move about half the diameter of the blade of the tool. So when you look at it from the side, you can say, it's about lined up to half. And then slowly start cutting. We'll get all these little chips. Now, because this is just a rough cut, I'm going to go to just past half of the tool. That way it's done a full cut. So that's the first pass of the rough cut done. Zoom in a little more. I can. So I moved the table up another 50 thousandths. So now my indicator reads 0 again because I've gone a whole 1/10 of an inch, or a whole 100 thousandths. So now I'm going to continue cutting. Okay, so that was 100 thousandths done. I'm going to go another 50. Now this is set to 150 thousandths, but still only a 50 thousandths depth of cut. So we don't want to cut off too much at a time. Okay, so that was 150 thousandths. Now I'm going to go another 50 to 200 thousandths. Okay, so that was 200 thousandths. Now I've moved it to 250 thousandths. Okay, so I've gone 250 thousandths, and the total I needed to get to was 286. So I need to go another 36 thousandths. But instead of doing that all at once, to get a better surface finish, I'm going to go 30 thousandths first, and then do a final pass of 6 thousandths. So we'll set this to 280 right there. Put a little bit more oil on it, and do our final rough cut pass. Okay, so now for the final pass, I'm going to move the table up that last 6 thousandths, and you can see we're getting pretty close to our line right there. There's just a little smidge left. Now for this final pass, I'm going to go pretty slow because we want to have a nice surface finish on the top here, and we want it to be nice and flat. So I'm going to move the part and the table a lot slower than I was for the rough cuts. So if you notice with this final cut and all of the final cuts on the surfaces, I've moved the tool a little bit past center, and that is to keep the conventional cutting going and avoid climb cutting. There we go. There we go. So now I'm done. I'm going to take the part out and do some quality control. Now be careful because these edges are pretty sharp. It'll focus. There are lots of burrs on there. So I'm going to take a rag and wipe all of the oil off of it, and be careful not to slice your finger on there. You can go this way. That way is okay, but don't go to the side because it will cut you like a knife. Okay, so I went away and did some quick deburring so it's not so sharp anymore. And now you can see the surface finish on there. You can actually tell which way the tool traveled. You can see it went around the outside and then came back to the middle. You can kind of follow that tool path. And this is very, very smooth on top. Okay, so we said that we wanted this to be 1.625. So let's measure it. And there we go. Focus. There we go. We are spot on 1.625. So that's how you set the Z height and do some face milling and regular milling.